Hello viewers, welcome to my channel, Second Math Hub, the solution to your math problems. We are still on bearings. We are looking at bearing problems. Question 2, I read, the bearing of Q from P is 300 degrees and the bearing of R from Q is 210 degrees. If Q is equidistant from P and R, we have to find the bearing of R from P. So when you analyze the question, you will see that three key informations have been given. The first one, the bearing of Q from P is 300 degrees. That is the first key information. Second key information, the bearing of R from Q is 210 degrees. And then lastly, we've been told that Q is equidistant from P and R. So these are the three key information that will guide us find the bearing of R from P. So let's quickly represent something. So now, the first one, the bearing of Q from P is 300 degrees. Between Q and P, where do we measure the 300 degrees? We said that in bearings, there is the keyword from P. So it means that we should measure 300 degrees from point P. So let's quickly do that. So this point here is P. So now from P, how do we measure 300 degrees? So we said that for the three figure bearing, angles are read from the geographical notes in the clockwise direction. So in the clockwise direction, let's measure 300 degrees. So from north to east, that measures 90 degrees. From north to south, 180 degrees. From north to west, 270 degrees. So clearly 300 degrees will be in this quadrant. So 270 degrees plus what angle will give us 300 degrees? So let's do some small calculations. 270 degrees plus what angle will give us 300 degrees? So clearly that is 30 degrees. That is 30 degrees. So let's quickly do that. It means that we have to measure 30 degrees from this quadrant. So this angle here measures 30 degrees, so that the bearing from point P here will be 90 plus 90 plus 90, that is 270, and 270 plus 30, 300. So from here to this point, this line, that is 300 degrees. So now, what point should be here? What point should be here? So this point here should be Q. This point here should be Q. So that is what we have done. The bearing of Q from P measures 300 degrees. So that is the first key information. Now the second one, the bearing of R from Q. So between R and Q, where do we draw or where do we measure the 210 degrees? Again, the key word here is from. So from where? From Q. So from Q, we have to measure 210 degrees. So we said that in three figure bearings, angles are read from the geographical north in the clockwise direction. So now, in the clockwise direction, let's measure 210 degrees. So from north to east, 90 degrees. From north to south, 180 degrees. So clearly you see that 210 degrees will be in this quadrant. So the question is 180 degrees plus what angle will give us 210 degrees? So let's do the calculation. 180 degrees plus what angle will give us 210 degrees. So clearly that is 30 degrees. 30 degrees. So it means that we have to measure 30 degrees from this quadrant. But again, in doing so, we also have to consider that Q is equidistant from P and R. So meaning that the distance from P to Q is the same as the distance from R to Q. So meaning that in your drawing, although it's not drawn to scale, but at least the length for line QP should also be the same as the length of line QR. So take note. So 30 degrees. 30 degrees from Q. So this angle here measures 30 degrees. 30. So that will give us 210 degrees in all. So what point should be here? What point should be here? So this point here is R. This point here is R. So now, again, we were told that Q is equidistant from P and R. Q is equidistant from P and R, meaning that this distance here, the distance from point P to Q, is the same as the distance from point R to Q. So that is why we have put these symbols along the lines. So now, what shape are we getting? What shape are we getting? You see that you are getting something like a triangle. So how then do we get a triangle out of this shape? So we have to join these 2 points. You have to join point R and point P with a straight line. So let's do that. So now we are having our triangle. We are having our triangle. Now, since this is core maths, in most cases, one of the interior angles must measure 90 degrees. So take note, since this is core maths, in most cases, one of the interior angles must measure 90 degrees. So let's look for that particular angle. So clearly you could see that this side, we can do some manipulations here to get the 90 degrees. So let's do that. Now, what is the measure of the angle here? The whole of this quadrant measures 90 degrees. We know that a quadrant measures 90 degrees. And this quadrant here has been divided into two. One part measuring 30 degrees. So meaning that the remaining quadrant should measure 60 degrees. So this angle here is 60 degrees. Now, what is the relationship between this angle and this angle? This angle and this angle. So here measures 60 degrees. So what angle should be here? So if you can recall from angle properties of parallel lines, you know that alternating angles are angles that are formed from the alphabet Z, as you can see. And then the angles inside the alphabet are alternating. And again, alternating angles are equal. So if here measures 60 degrees, then this angle here must also measure 60 degrees. So if this angle here measures 60 degrees, then this angle here must also measure 60 degrees. So as you can see, 30 degrees plus 60 degrees, that should give us 90 degrees. So we have our 90 degrees angle. We have our 90 degrees angle here. So that is what we have done. So now again, this triangle here becomes a right angle triangle. So let me draw it here. We have our right angle triangle. We have our right angle triangle. So this side here measures 90 degrees. And then this point here is R, here is Q, and then here is P. So we want the angles here. We know that line RQ is the same as line PQ. So if the acute angle here measures K, then this angle here too must measure K. Now let's calculate for K. Let's calculate the value of K. Let's calculate the value of K. So now, that will be this K here plus K plus 90 degrees must be equal to 180 degrees, because we know that the sum of the interior angles of any triangle should be equal to 180 degrees. So now K plus K, 2K plus 90 is equal to 180. So 180, we transpose 90 to the right, it becomes minus 90. So we have 2K is equal to 180 minus 90, 90. So we are looking for K, so we divide both sides by 2. So we end up getting 90 divided by 2, which is 45 degrees, meaning that each angle here measures 45 degrees. Each angle here, so this angle here measures 45 degrees, and then the whole of this angle here also measures 45 degrees. But again, this angle here has also been divided into two. One part measuring 30 degrees. So 30 degrees plus what angle will give us the total measure of 45 degrees. So clearly 30 degrees plus 15 degrees will give us 45 degrees. The whole of this acute angle measures 45. The whole of this acute angle measures 45. But this side has been divided into two. One part measuring 30 degrees. So the remaining part must be 15 degrees. You could see that 30 degrees plus 15 degrees, that will also give us 45 degrees. So that is what we have done. Now, what is our main question? What is our goal here? Now, our goal here is to find the bearing of R from P. The bearing of R from where? From P. So from P, we are to measure the bearing until we get to the line connecting point R. So the bearing of R from P will be the angle measured from the geographical north at point P until we get to the line connecting R. So we are looking at this angle. So now, how do we get this angle? We know that from north to east, that is 90 degrees. From east to south, another 90 degrees. So there is an unknown angle here. We need to look for this angle. So I'm placing theta here to represent this angle. Now, how do we calculate for theta? Again, let's consider this quadrant. Let's consider this particular quadrant. So this quadrant here, we know that the total measure of a quadrant is 90 degrees. So this quadrant here, but again, you can see that the quadrant has been divided into two. One part measuring 15 degrees, and the other part measuring theta. And we know that the sum of the angle in a quadrant should be 90. So let's solve for theta. So theta is equal to 90 minus 15. So theta is equal to, what is 90 minus 15? 90 minus 15, that is giving me 75 degrees. So this angle theta here measures 75 degrees. So with this, we can finally find the bearing of R from P. Can easily do that. So now let's measure the bearing of R from P. So from P, from north to east, that is 90 degrees. And then from east to south, another 90 degrees. And then finally, from south to the line that connects point R, that is theta. And what do we get for theta? We had 75 degrees. So 90 degrees plus 90 degrees plus 75 degrees. And that is giving me 255 degrees. So in conclusion, the bearing of R from P measures 255 degrees. I hope you enjoyed the lesson. See you next time.